What kind of uh, robot partner you want? A skinny, fat, or medium size? What kind of body type you love so that your robot partners will have that exactly that body type, athletic or very agile, can withstand any type of physical stress as long as different types of intimate physical acts are concerned.
He who disturbs the slumber of the gods shall face a riddle that cannot be solved.
It's meaningless. A dead end.
Before we proceed, let me tell you one thing. If you have not subscribed yet, please subscribe. It means a lot to me. And if you have already subscribed, tons of thanks for your support.
You
So basically,
always know how to make me
at the heart of
laugh.
every robot is its structural frame or chassis. This is the physical foundation that gives the robot its shape, supports all its components, and
It's my
withstands the physical stresses.
specialty.
Now, what happens is it encounters during different types of physical stresses with you. As long as your intention is, you know, what is your intention, what you want to do with your robot partner. I don't know, you know. So during that operation, maybe in your bedroom, in your garden, in your dining room, anywhere else, it must withstand that physical stress, right? So much like a human skeleton, it works in the same principle. This frame of our robot partner is the scaffold upon which everything else, that means we already have talked about motors, sensors, wires, controllers, isn't it? So everything is built upon that skeleton. Its design is a critical engineering challenge, no doubt, balancing the need for robustness with the demands of mobility and efficiency. A well designed frame is not just a passive structure, it is fundamental to the robot's overall performance. Now, here is a balancing act because with strength comes stiffness and weight. So, the effectiveness of a robot's frame hinges on a careful trade off between three key properties. Yeah, one is strength, one is stiffness, and weight. Now, if your robot partner is too weighty, it will be difficult for you to handle it for any purpose. If it is strength is too much, then it could be dangerous for you. And if it is stiff, it doesn't move on your bed, that is also not a good idea. So finding the right balance is crucial and depends entirely on the robot's intended task. What type of task is you can expect from your robot partner, that is really very important. So let us just touch upon this very briefly in this short video. Let us take a look at strength, stiffness, and weight. Now let's first start with strength. Strength is the frame's ability to resist breaking or permanent bending under force. Because God knows what you want to do with your robot partner. No one knows. In fact, I don't know. So it must be built in such principle that its frame's ability to resist breaking, first of all, and also permanent bending under forces, it could be deformed. So it must resist that. Normally, an industrial robot arm lifting heavy car parts requires immense strength. That's a different topic altogether, because we are concerned about lab robots, not industrial robots. So, in that case, industrial robots' arms are very strength, have very immense strength, because it would avoid catastrophic failure. The frame must be able to handle not only the weight of the payload but also the dynamic forces generated by its own rapid movements. Secondly comes stiffness or rigidity. Now, you don't want a very rigid, very stiff robot, isn't it? While related to strength, stiffness is quite distinct, because it refers to the frame's ability to resist deforming or flexing under load. This is critical for precision. Imagine a surgical robot. If its arm flexes even slightly, it could miss its target by a crucial millimeter, and that could be fatal for the patient. A stiff frame ensures that the robot's movements are precise and repeatable, as the structure doesn't give or wobble during operation. Thirdly comes weight. The mass of the frame is a paramount consideration. As I said, if your robot partner is have immense weight, it could be very difficult for you to handle it. So a lighter frame is better choice. So lighter frame requires less energy to move. It has some advantages also. It requires less energy to move, leading to better battery life, and especially for mobile robots, and faster acceleration for all types of robots. It can do complex tasks much faster than other robots. And if you consider a flying drone or a bipedal robot, legged robot, minimizing weight is very essential, because for every function it is needed. However, reducing weight can often compromise strength and stiffness. Remember, if you want maybe you love a skinny robot. It happens. Some people love skinny partner. So you love a skinny robot. So it's very light. But at the same time, you need to compromise with strength and stiffness, creating the core design challenge. That means overall, the design principle depends very heavily on these three factors: strength, stiffness, and weight. And it's a very delicate balance altogether. So I hope you have an idea about the foundation of your robot partner strength and purpose. So that is it. Thank you for joining us on this journey. Let's continue this conversation in the comments below. If you like the video, please hit the bell icon to get notified, and don't forget to like with your friends, share, and subscribe for more insights. If you have already subscribed, tons of thanks for your support. It means a lot to me. And please consider signing up for membership zone to support Wooden Slate, so that we can make it better and better. See you in the next video. Till then, goodbye. Take care and stay safe.